Hello everyone. Today we will discuss AWS Route 53 DNS and traffic routing. In this lecture, we will cover AWS Route 53 DNS and traffic routing, DNS record types, routing policies, health checks, and production-level design. AWS Route 53 DNS and traffic routing. Targets include hosted zones, application load balancer, CloudFront distribution, Amplify app, EC2 IP address, and S3 website. Public hosted zone is used for internet-facing DNS, while private hosted zone is used only inside of VPC. When a user types example.com, the Route 53 DNS resolver handles the request and routes it to the correct destination. Route 53 is a highly available and scalable DNS service that also supports domain registration and advanced traffic management features. It provides a 100% SLA, which is the highest among AWS services. Public hosted zones are accessible from the internet, while private hosted zones are only accessible within a VPC. Alias records are used to point directly to AWS resources without extra DNS query cost. Route 53 is AWS's DNS service that converts domain names into IP addresses. A hosted zone is a container that holds DNS records for a domain. Public hosted zones are used for internet applications, while private hosted zones are used for internal service discovery inside VPCs. Route 53 also provides health checks, domain registration, and advanced routing policies that go beyond basic DNS functionality. DNS record types. DNS record types include alias record targets such as ALB, NLB, CloudFront, Amplify, S3 website endpoint, and other Route 53 records. Other important records include MX for email routing, TXT for verification and SPF, NS for name server delegation, and SOA for zone authority. An A record maps a domain to an IPv4 address, while an AAA record maps it to IPv6. A CNAME maps one domain name to another, while alias is AWS specific and maps directly to AWS resources. The most important difference is that CNAME cannot be used for the root domain, like example.com, while alias can be used at the root and directly connects to AWS services like ALB or CloudFront, making it the preferred option in AWS environments. Routing policies. Routing policies in Route 53 allow traffic control based on different rules. Geolocation routing sends users to different endpoints based on their location, such as EU users to EU servers and US users to US servers. Failover routing uses a primary and secondary setup, where traffic automatically switches if the primary fails. Latency-based routing sends users to the region with the lowest network delay. Weighted routing splits traffic between multiple endpoints based on percentage, such as 80% and 20%. Simple routing sends all traffic to a single endpoint without any logic. These routing policies make DNS intelligent by allowing control based on location, performance, and system health, which is especially useful for global applications. Health checks. Health checks in Route 53 monitor the availability of endpoints from multiple AWS locations. If an endpoint fails health checks, it is automatically removed from DNS routing. These checks can be HTTP, HTTPS, or TCP-based, and can also trigger alerts using SNS. They verify HTTP status codes like 2XX and 3XX, and run at intervals of 10 or 30 seconds, depending on configuration. Failure threshold defines how many failed checks are required before marking an endpoint unhealthy. Calculated health checks allow combining multiple checks together, and CloudWatch alarms can also be used for monitoring. In production systems, a dedicated health endpoint is used to verify not just the application, but also its dependencies like database and cache to ensure full system health. Production Route 53 design. Production Route 53 design uses both public and private hosted zones together. The public hosted zone handles internet traffic where the main domain points to CloudFront using alias records. API subdomains point to ALB, and staging environments point to separate load balancers. The private hosted zone is used for internal communication inside of VPC, where services use DNS names like rds.internal.example.com instead of hard-coded IP addresses. This makes the system flexible, scalable, and easier to manage in real-world environments. Thank you for watching.